Hello everyone. In this video, we are going to see a number conversion, that is binary to decimal. We already seen in the previous video how to convert decimal values to binary, including the decimal fractions to binary. Here you are going to see the reverse process, how to convert binary to decimal. Any binary number can be converted to its decimal equivalent by simply by summing together the weights of the various positions in the binary number which contain 1. So here once you read it, you won't able to understand what it is, but when you see the example you may understand. So we will see an example. Consider a binary number 11011. So in this you got say 4 ones and 1 0. So here what you have to do is you have to sum the weights of the position 1. That is, you can see any number, the position which the number 1 is there should be multiplied with the weight and then summed up. Okay, that's what they mean. Okay, we'll see with an example so you'll understand what it is. So you just write the values, positional values like this. Say, write the number 11011. Just above that, start from the right hand side. Put 2 to the power 0 for the first rightmost digit. Then the previous digit 2 to the power 1, 2 to the power 2, 2 to the power 3 and 2 to the power 4. So this will be, after writing this, you know how to write and how to solve the problem. Okay, once you do that, you can see the number 1, that is to be multiplied with the weight, that is 2 to the power 4. Second number, you have to sum up the values again. Okay, so 1 into 2 to the power 4 plus then the previous value 1 into 2 to the power 3. The next value is 0 into 2 to the power 2. Then you have plus 1 into 2 to the power 1 and finally plus 1 into 2 to the power 0. So once you do this, what you can assume that you are going to yield answers wherever you have ones. But when you have 0 in some position, it's not necessary to calculate that, because once you multiply any number with 0, it becomes 0. For illustration purpose, we are shown here. Okay, you can skip this step. So wherever you have 0, you can skip. But remember to skip this weight. 2 to the power 2 should be skipped. If you have confusion there, then you can write as it is like this. And then finally you can get the answer by omitting that number. So you can see here, once you multiply, that is, find the weight of this power, that is 2 to the power 4 is 16. Okay, which is multiplied by 1, so the number will be the same. So 16. Next 2 to the power 3 is 8. So you have to add that, and then 2 to the power 2 is 4. But multiply it with 0, it becomes 0 again. So you have to put 0 here. Then 2 to the power 1 is 2, which is multiplied by 1, so it will become 2. And then finally 2 to the power 0 is 1, and multiplied by 1 you will get 1. So these are the numbers you got from the previous step. Okay, now you are going to add these values, you are going to get the decimal equivalent for the binary number 11011. So this is how you are going to solve this. Okay, you are going to multiply with the 2 powers, that is weight of the positional values. Okay, and then you write the decimal value and then put the base 10. Okay, that indicates it is a decimal value. We will see one more question. Convert 10110101. So this is a binary number base 2 to be converted to decimal value. So as we discussed earlier, just write the numbers from 2 to the power 0 to the numbers till 2 to the power 7 here. Okay, so you got 8 digits here, so it goes on like that. Now just write as it is. So 1 into 2 to the power 7 plus 0 into 2 to the power 6 plus 1 into 2 to the power 5 plus 1 into 2 to the power 4 plus 0 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. So you can see some zeros are there. You can skip the step because anyway you are going to get 0. Okay, so no need to write that. But if you are confusion what power has to be used for each digit, then you can write it like this. Okay, no issue in that. Now the next step is just 2 to the power. You know that how to get 128, all that you would have seen in the sum of powers 2 method. So start from 2 to the power 0, just put the byte number, that is 1, 2, 4, 8, 16, 32, 64 and 128. So these are nothing but the bits and bytes numbers. So you remember that number, so you can easily fill in the numbers here. Okay, so here you got 128, then you got 64, then 32, 16, 8, 4, 2, 1. Okay, so these are the bits and bytes numbers. So 2 to the power 7 is 128. 2 to the power 6 is already it is multiplied with 0, so you are getting 0 here. And then you got 2 to the power 5, that is 32. And 2 to the power 4 is 16. And then you got multiplied with 0, so you are getting 0 here. That is 2 to the power 3 is 8, which is multiplied by 0, you are getting 0. And 2 to the power 2 is 4, so you are getting 4 here. And 2 to the power 1 is 2, which is multiplied by 0, you are getting 0 again. So finally you got 2 to the power 0, that is 1, which is multiplied by 1, you are getting 1. So this is the answer what you got from the previous step. Now add all these, you are getting a decimal equivalent 181 base 10, that is the decimal equivalent for this binary number. Next you are going to convert binary fraction to decimal. To find the decimal equivalent of binary fraction, take the sum of products of each digit value and its position value. Same here also you are going to multiply, but only difference is you are going to use say for after decimal digit. Okay, before decimal digit you started with 2 to the power 0, and then you went on like that, 2 to the power 0, 2 to the power 1, 2 to the power 2, like that. But in fractional part you have to start from 2 to the power minus 1 and goes in left to right order. So minus 1, 2 to the power minus 2, 2 to the power minus 3, 2 to the power minus 4. So here for example 0.0101 should be written like that, and then you just write above that 2 to the power minus 1, 2 to the power minus 2, 2 to the power minus 3 and 2 to the power minus 4. So now we are going to see how to solve this. Now as usual we discussed before, we are not going to calculate the zero number, because when you multiply anything with 0 it becomes 0. So only the number where the position number where you have 1, the weight has to be calculated. So you can just write like that, 0 into 2 to the power minus 1 plus 1 into 2 to the power minus 2 plus 0 into 2 to the power minus 3 plus 1 into 2 to the power minus 4. So once you do that, what you can assume here is, you should know what is this 2 to the power minus 1 is. 2 to the power minus 1, for example, if it is square, 2 to the power 2, square root is 2 to the power 1 by 2. Okay, so here it will be like this. So here 2 to the power minus 1 is nothing but 1 by 2, 2 to the power minus 2 is 1 by 4, 2 to the power minus 3 is 1 by 8, and 2 to the power minus 4 is 1 by 16. So this also can be written in the bits and byte order, that is 2, 4, 8, 16. So it goes on like that. But you have to put one fractional part, that is 1 divided by 2, 1 divided by 4, 1 divided by 8 and 1 divided by 16. Now the first part is 0, so no need of calculating this. Okay, so if you calculate this, what happens is 1 by 2 is nothing but 0.5. Okay, so you get 0.5. Since it is 0 here, we are multiplying 0.5 with 0, so you are getting 0 again. Next one, 1 by 4 is 0.25. Okay, so that will be multiplied by 1 and you are getting this. So next value again it is 0.125. Okay, so that will be multiplied with 0. Since it is multiplied by 0, you are getting the same number, that is 0. Then finally you got 1 by 16 is nothing but 0.0625, which is multiplied by 1. So you are getting these two values. So 0 plus 0.25 plus 0 plus 0.0625. Now add these two numbers, you are getting 0.3125, that is the decimal equivalent for the binary fractions. Same like the previous video, we are going to convert both the integer part and the fractional part. So you got a conversion like 1101.0000101 base 2. So you can see here, first you write the integer part, then write the fractional part. So integer part start from 2 to the power 0 and write from right to left. And decimal fractional part you start from 2 to the power minus 1, write from left to right. So integer part you can see 2 to the power 0 to 2 to the power 3 is there. And in fractional part you can see 2 to the power minus 1 to 2 to the power minus 6 is there. So you might be wondering like previous one, how to write this. So 2 to the power minus 1 is 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32, 1 by 64. So that's how we are going to write it. So just write it as it is here, 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. So that is the integer part, plus add the remaining again. So 0 into 2 to the power minus 1 plus 0 into 2 to the power minus 2 plus 0 into 2 to the power minus 3 plus 1 into 2 to the power minus 4 plus 0 into 2 to the power minus 5 plus 1 into 2 to the power minus 6. So this as it is just right below, multiply with the weightages. Now, as we discussed earlier, you are going to skip the 0 part, so you are going to add only the position value which has 1. So 2 to the power 3 is 8, so you are getting the first number is 8, second number is again 1, so it is 2 to the power 2 is 4, and 2 to the power 1 which has 0 value, so it is 0, and 2 to the power 1 0 is 1, so you are getting 1. So 8, 4, 1, that is the integer part. Now the fraction part, you got 3 zeros, so just write 3 zeros here. Now, as we discussed before, this is first value is 2 to the minus 1 is 1 by 2, 1 by 4, 1 by 8 and 1 by 16. So in 1 by 16 you got 1, right? So you have to write 1 by 16 plus 0 plus the final one is 1 by 64. Okay. So you have to find the fractional part of this. Okay, that is the important part, because unfortunately you cannot use calculator in exam. So you have to do manual calculation and find the values for the decimal part. Okay, so this is the value you are going to get. So 8 plus 4 plus 1 is 13, and then plus 1 by 16 you are getting 0.0625, plus 1 by 64 you are getting 0.015625. So here you can notice one more thing, the values will not change, whether 1 by 2 or 1 by 4 or 1 by 8, the values will not be changed anyway. So if you know the answers, decimal values beforehand, you can directly write, or you have to do manual calculation and then finally add it. Now adding all this, you are getting an answer 13.078125. That is the decimal equivalent for the binary fraction given. So hope you understood these conversions. Okay, so already we have seen decimal to binary, now binary to decimal. Okay, so we will meet in the next video of conversions. Until then, thank you.